Okay, in this video I'm going to talk about the random number generator if we want to generate random numbers. Now a generator is just code, like a function, right, that generates or returns some value. And if we want to generate a random number, then of course we use a random number generator. Now the important thing is we need to seed this random number generator, otherwise we will get the same sequence or pattern of numbers every time we run the program. Now this is a pseudo random number generator. The generator returns a random number, but the sequence of numbers returned can be reproduced later if the starting point is known. So in other words, the returned numbers are deterministic. So you have the same starting point each time, such as 0, then it's going to generate the same sequence of numbers each time. If you don't get this right now, it will make more sense when I actually show you some of the examples. So how do we seed it? Well, at the top here you can see we use srand, and then we use another function within that called time. We pass that a null pointer, as we'll see why later, to seed the random number generator. This is called seeding the random number generator. You feed it a starting point, so each time you use the random number generator, it's going to be using that seed as a starting point basically. And you basically want to change that. As I mentioned, each time if you feed it the same starting point each time, it's going to give you the same sequence of numbers, right? And sometimes that is what you want, but in some cases that's not what you want. Let's say you roll a dice 6 times to calculate some value in a game maybe. You don't want that to be the exact same dice rolls each time. And so that is why instead of doing 0 in the srand function where we see the random number generator, instead of passing something like 1 in there or 0, we pass in this time function. I will talk about that in more detail in just a second. So we need to use the #include ctime for that time function, and then that time function where we pass it in null pointer is going to return the current calendar time obtained from the system clock. So each time we run the program, it will return a different value, and basically this means that we ensure that the number generator is seeded with a different number each time by using this time function. Well, actually each time we seed it with that srand function, this will allow us to generate a different sequence of values with the random function. So at the bottom here, that is the random function that we'll use to actually generate the random number. We need to #include that cstd_lib, okay, that standard library for random, and that random function is going to return a random positive integer. Alright, so for the upcoming examples, you can see I have #include iostream for input/output. Then I also have the C standard library for the rand function, and also the ctime include for the time function. And we'll see those a bit later in another subsection and another example. I just want to start here with how we can see what the maximum value can be for the random function. So the maximum value that it will return, because it's going to return values between 0 and whatever the maximum value is on your system. And in some cases it might be handy to know, how to check for that value if you get strange behavior. So you can see I just print this out, and then I use this random max, which is a global constant. This will give us the value on our machine for what that maximum value is. That again is going to be returned by the rand function. So if I build and run this, you can see it is 32767. Okay, so in this example, once again, I'm doing those includes that I talked about. So in the main function, I go and declare this random num variable, and then I have a for loop where with each repetition, this random num variable is going to get assigned some random value, and then we simply print that out as well. And you can do long lists like 5 or 5 to 10 numbers or something like that, but I chose 3. That's enough for our purpose here. I'll just build and run this, and you see we get 41, this number here, and 6334. Let's build and run that again, and you'll see you get the same sequence of numbers. Now let's say, okay, we go and rebuild this thing. Instead of building, let's maybe rebuild it instead. Build and run, you get the same numbers. So basically it's going to give you the same sequence of numbers each time. And to change that, you need to seed it with a different value. Okay, so let's look at the seed function, which will seed this random number generator. And let's just go and put some value in here, such as 5. Now as an exercise, what you can go and do, so maybe go and add another integer called seed number or something like that, and then you do an input. So input a value to that from the console, and then each time you run the program, you go and enter another value, 3, 5, and so forth, and then you can go and see what happens. Now just for conciseness, I'm not going to do that. I'm just going to do it like this and type in a value. You can see what it takes in here is the seed value, which is an unsigned integer. So let's build and run this. And so we get a different value. Alright, let's run this again. Now we get those same values again. So we basically have the same problem, but we do get different values at least. If we set that to 1, we are going to get the same values that we got originally. We'll see this again later on in the video. But basically what's going to happen is if you pass a seed of 1, that generator is going to be reinitialized to its initial value. And because of that, of course, it's going to give you the same sequence of numbers that you had originally. Well, this can be handy in certain situations. So if we want to get a unique sequence of values each time we run the program, once again we can use this time function. Alright, now in the time function you can see it returns something called time underscore t. So it doesn't return an integer or a float or something like that. It returns this time underscore t object. It also has a parameter which has a pointer, and the time value will be stored in that, so in the object that you pass in. Or it can be a null pointer, so you can pass in null pointer, in which case the parameter is simply not used, and then the function is still going to return the type with that result. We don't really care about the time that it returns. All we want is for this to once again seed our random number generator. And the time function itself once again is going to return or get the current calendar time. So all we are going to do here is you'll often see 0 being passed in or null. But from C++11 we have null pointer. So we're not passing anything in here in this parameter to get a value back. So in that case we're simply passing it null pointer. Okay, so I'm going to build and run that. It compiles fine and everything. We get these numbers, so 24, 29, so on. Build and run again, and we get a different set of numbers or a different sequence of numbers. Build and run again, and once again we get different numbers. So that's very handy, but what I'll go and do is, so I do this, I have a for loop which will print out those numbers like before we do the seed. Then I'll do this again, so I'll do the same as up here, but instead of doing time here, I'll do 1. Control F5 to build and run. So I'll just go and do something like this. And this might give you the results that you would expect. Firstly, we get the original values as we had it before. Also note that this will of course be different on your machine, right? And then we get an actual set of different values. And then we get the original set of values back again by setting the seed here to 1. And each time we run this, you can see these values in the center here should be different. As you can see. I'll just do some cleanup before we move on to the next section, because this is very handy, so we can see how to generate, depending on what we want, we can generate unique numbers each time we run the program. But let's say we want to generate random numbers between 0 to 10 or 1 to 10 or 5 to 15, something like that, right? How do we manipulate this so that we can get the results from this that we want? So let's say we want to do a die roll in a game, which is very handy, especially for learning C++. Let's say you build some sort of role-playing game, text-based RPG, and you want, let's say, D6 and D12, T20 maybe, and so forth, these different die rolls. You don't want a value of 18,000 for that, right? So in the next subsections, we'll look at how we can get the values that we want from these functions. Okay, so in the next section, I want to talk about how we can generate random numbers within a range, 0 to 9, for example. So we can do the rand function with the modulus operator, that a percentage character. Now, of course, with the modulus operator, the only remainders that can be obtained are 0 to divisor minus 1. So if you divide by 50, that modulus operation is not going to give you 50, right? It's never going to give you the same value as the divisor. It's going to give you 0 to that number minus 1. So you can see a quick example of what that will look like. But we start with 0 here. So let's say we don't want to start with 0. How can we do that? So if you want to generate numbers starting with values other than 0, firstly you determine r, which is just some variable, instead of doing x or y or something like that. So you determine r by counting how many possible numbers there are in your desired range. So an example is, in the range 20 to 40, 20 inclusive, that r variable will be 21, not 20. Now on the next slide I'm going to give you an easy way of calculating this stuff. Then we go and use the expression rand, so that rand function, plus that r variable. So from the previous example we have rand plus 21. Now we also want to add the starting or the smallest number in the expressions, so your lower bound. So let's say in the range of 20 to 40, once again, 20 will be your smallest number, right? So in the example here you can see int x. Let's say we want to store that calculation. Int x is equal to 20 plus that rand function, the modulus operator, and r, which in this case is 21. How does this calculation work? Well, the smallest value is 20 plus 0, which is 20. So remember, when we do the rand function with the modulus and that r variable, so in this case 21, that can return 0 to 20. So if that is 0, then our minimum number that we'll get is 20. But we can also get up to 20 from that calculation. And 20 plus 20 is 40. So that is how we can get values in the range 20 to 40. So it's important to note here that that r variable that I'm talking about is not the upper bound. So there's a difference between the lower bound and the upper bound and this r variable. So in the range 20 to 40, the lower bound value will be 20. So your min value will be 20. The max value or the upper bound value will be 40. That is obviously different in this calculation to 21 or the r variable in this example. And then just a simple example down here, you can do x or int x is equal to that rand function, the modulus operator, and 10 plus 1. So x is going to be in the range 1 to 10, because the max value that it can get from that rand modulus 10 is going to be 9. It can also be 0, and in each case we do plus 1. So again 1 to 10. In some examples you'll see it written out, similar to how I have it with this final example, but I prefer the other example that I showed you, mainly because it's easy to see the lower bound. So 20 to some other value, 22r. And that's just a personal preference. It's going to give you the same result. I just prefer the other examples because it's easy to see once again. Okay, this will give me this lower bounds value to what? Well, we go and calculate what that rand modulus something will give us. And then you just do the calculation. So 20 plus whatever that will give you, 20. It's easy to calculate. There is a formula that will make this easy as well. So right here, the formula to generate a random number in the range min max. So this is more or less the format that we'll be using when you talk about a range between brackets. I'm just using min and max as the variables here instead of x and y or something like that. So the formula basically is min plus that rand function, whatever that returns, and the modulus of max plus 1 in brackets minus that minimum value again, that lower bounds value. And it's max plus 1 once again because that modulus operator is going to give you a value from 0 to the divisor minus 1. So you want to add 1 to that. Otherwise you're not going to get the upper bound value that you're looking for, right? So here's a quick example, a calculation in the range 20 to 40. As we had it in the previous example on the previous slide. So I'm simply copying that formula and I'm replacing the value. So 20 plus that rand function, we have modulus 40 plus 1 and minus 20 in those brackets. So R in that calculation is going to be 21, where R again from the previous slide is the amount of values in your range. So in this case, once again, 21. So in the next example, we actually know what this R value is, so I'm just going to use it. But you can also use this formula and use those min and max, for example, as variables, or use lower bounds, upper bounds, and so on, depending on your preferences or what's easier for you to read, because you might come back to a program like, 2 years from now and then have to understand what's going on. Before we end this video off, let's look at a quick example in Visual Studio. So in the main function, we can see we have the random num variable again. Also a variable called rolls that I set to 3. And this is set to how many dice rolls we want. So in this case, I just want 3 dice rolls. So if we go and do the for loop, we only get 3 dice rolls with each run of the program basically. I have the R variable, which is the desired amount of values in the range. So in this case, it's 6. And the lower bound, which is the starting value in the range basically. Now, of course, if you go and use the formula, you will not be using R. You can just pass in the lower bound and the upper bound's values, so the min and max values. So in this case, R is actually equal to what the upper bound would have been, right, inclusive. But if you have a range such as 20 to 40, R will not be 40. So R is not the same as your upper bound. So once again, you have to remember that R is the amount of values in the range. So in that case, it would be 21. Whereas here R is 6 because 1 inclusive to 6 is 6 values. If we had a lower bound of 0 and an upper bound of 6, then R would have been 7. Alright, so here I simply seed the random number generator again using that time function, passing in the null pointer, and once again we have the for loop. Here I'm generating the d6 dice rolls. I'm doing the amount of rolls, so in this case 3. Of course, you can go and write, cin to the amount of rolls, pass it in from the console and so on. But in this case, once again, for conciseness, I just pass it in the integer literal. Alright, so in the for loop, we calculate the random number, which is once again a lower bound, plus that rand function, the modulus operator, and the R variable, and then we simply print that out. So this, of course, is where it go and do that expression or calculation. If you do not use R, if you use lower bound and upper bound or min and max, then you can go and do that here if you want. I'm just doing it this way because I know ahead of time what R is. So it's up to you how you want to calculate that. You can run that a couple of times and that will work fine. So now you can see some of the pieces of the puzzle that you can put together if you want to build, let's say, a text-based role-playing game, for example. That'll be a good exercise to learn C++. And then once again, it's fairly easy to change this to a D12 or a D20 and so on for the different dice types that you have, so with the varying number of faces on them. Finally, I'd like to note that you may get a warning, so I'll open up the error list here or the output, and let's go and look at the output, for example. Argument conversion from this type to unsigned int, possible loss of data. Okay. And that is because if I click in here between the parentheses for the srand function and I do Ctrl-Shift spacebar, then we see that takes in an unsigned int, and the time function right here is going to return what? Ctrl-Shift spacebar is going to return a type of time_t, and that is a different type, and that is why we get this possible loss of data warning. Now, of course, this is not a big deal, but typically we want to get rid of those warnings. So we can do a conversion. We've seen casting before, we can do this type of casting, alright? So we cast whatever this function right here returns to an unsigned integer, and if I Ctrl-B to build now, that warning will go away, but it's best to use the static cast, so that's what I'll do. Once more, whatever this time function returns, we are going to cast. Using static cast, what do we want to cast to? We want to cast to an unsigned integer. Okay, we place that between these angle brackets, and then we pass that result into the srand function, the seed function. Build a run and you'll see that works fine. We don't get any warnings. The lesson in this is to pay attention to the formal parameters, or in other words, the types of arguments that a function will accept. And with this, we are going to wrap up this lecture on the random number generator. I hope you found it interesting. In the future, we'll do a couple of exercises where we'll use the random number generator. Alright, that is it for now. I'll see you next time.